All right. Hello, everyone. This will be an introduction to chemistry. Chemistry is one of my favorite topics. I Hello, everyone. This will be an introduction to chemistry. It's one of my favorite field of research that has discovered so many cool and interesting and important things in everyone's lives. Um, there are a lot of questions that people have about science and questions I'd like to help people understand why this is important in their life. Um, because a lot of this stuff, for one, isn't as complicated as I think a lot of people kind of make it out to be. I think a lot really be understood. Now, the more advanced stuff, I think, yeah, that's gonna take a while, but hopefully I can help people get that all cleared up. I hope. Let's get started. So, what is chemistry? Well, chemistry is the central science. In science, very broadly, we consider there to be three fields. And whilst there are more, and while many fields are kind of interdisciplinary, broadly in science we consider there to be three. Those are biology, chemistry, and physics. Biology is probably the easiest to understand and to define about what exactly we're talking about. Biology is the understanding, or the study of life. Anything living, whether we're talking about cells or bacteria, whether we're talking about animals or us. This encompasses things like anatomy and physiology, which is the study of the human body, its form, and how it functions. Um, Cells are what make up all of life, and how these cells differ in their structure can affect uh, how they actually function in our world. And it's a really interesting field. And for those of you out there who might be interested in medicine, biology is really a part of medicine. Next, I'd like to discuss the central science, which is what I'll be mostly talking about today, and that's chemistry. Now, for those of you who may have seen Breaking Bad, Walter White describes chemistry as the study of change. Now, I think that's an interesting definition, and then of course from a narrative perspective in the show, it makes sense for him to say the study of change because it's kind of implicating, how his character changes and how chemistry mirrors that. But that's actually a pretty good definition, but I think it's a little incomplete. There's a YouTube channel out there called Periodic Table of Videos, and they the main scientist guy who is responsible for those videos. I like the way he phrases it better. The study of how matter changes. I really really like that definition because at the end of the day, almost every time chemistry comes down to compound A, compound B, and they combine to make what? Now, to go from compound A and B to their product is, it's chemistry, so it's very, very complicated, but if you really boil it down, that's usually what we're talking about. So I think how matter changes, the study of how matter changes, is a very accurate definition, and I think it's important to keep that in the back of your head. And now there's physics, and this can be a little tricky, especially you can see my definition here. The fundamental study of matter and energy. I like to think of physics as a little more fundamental. It's a little more mathematically rigorous than chemistry and biology. If you want to study physics, you really need to love math. It's a very rigorous field like that. But I think what makes it different, probably in layman's terms, is it's really kind of studying the mechanism behind how a lot of various phenomena happen. So if you throw a ball, for example, physics might tell you if you give a ball a certain force, physics may give you an answer to how far it travels, how long it'll stay in the air, through things like explains physical phenomena like gravity. It explains fluids. It explains heat and how heat is transferred. A lot of these very, very fundamental ideas are explained by the field of physics. Now I'd like to discuss some of the fields that are in chemistry. I'm trying to get this presentation to load. And it's hard to say that there are only 5 fields in chemistry. It's a little bit of a simplification, but I think for the huge majority of people who can consider themselves chemists, these 5 fields probably encompass just about everyone. There probably are exceptions, and sometimes people are very much in between disciplines, like there may be physical biochemists. They may be studying like the physics of proteins, so it might be kind of hard to say exactly where they fit in. But in general, these are the five sort of fields that we consider in chemistry. The first one I'd like to discuss is biochemistry. This field is the field of biology, but from a chemical perspective. So much of biology, at the very most basic level, comes down to these different molecules, these different large molecules that are very complicated. And how do these molecules function to make life happen? And how can we utilize those functions? How can we understand those functions so that we can solve biological problems? So proteins, for example, many proteins are these big, long chains made of just repeating individual kind of smaller components that all came together to form this huge, long structure. And we're kind of looking at how those huge, long structures can kind of fold, they kind of intertwine, how they can interact with each other to make this bigger molecule, which is the protein that we know, and we can actually do various tasks. Understanding that can be important. Understanding things like diseases. It can affect reactions in the body. So much of biology can be understood through chemistry. It's really fascinating. Next, I'd like to talk about organic chemistry. Now, this is the type of chemistry people probably think of when you mention chemistry. It really is the kind of the bread and butter of most chemistry. It's usually various syntheses. So if you have some compound you're making, organic chemistry typically is how do we actually make that compound? So if we go back to Breaking Bad, Walter White's wondering, well, how can I make a synthesis of methamphetamine? And you can see in his notes he writes it out, and that's really typically how an organic chemist would do it. We start with these starting materials, we combine them in this way, in this order, with these temperatures, in such a way, and you get your product. Next, I'd like to talk about analytical chemistry. Now, analytical chemistry is, well, it's all about analyses. It's about analyzing compounds. So, there are a lot of examples in this. Of course, you can use analytical chemistry as a part of all the other disciplines. Like, if you're in organic chemistry, you want to know, like, how pure is my compound? What instruments can I use to test how pure my compound is? So I think that's pretty obvious and straightforward. But there's so much more to analytical chemistry. For example, forensics. A detective comes to you, and at the scene of the crime, they found a strand of hair that doesn't belong to the person who died. So they're very suspect of it. So they bring it into you, and you can do tests. It's probably a DNA test. I'm not sure how hair DNA tests works, but you could bring it into the lab and do various chemical or even biological tests on the strand of hair. You can come back to the detectives and maybe match that DNA to a database and come back to the detectives and say, that hair matches this person. And that can really help them determine who might have actually committed that crime. Another huge part of analytical chemistry is the environment. In Flint, Michigan, they had impurities in their water, and it's really important, for all of us to know how safe is our drinking water, our food. Are there impurities in it? Of course, there's going to be some impurities, right? Like it's not realistic to have water that's completely 100%, just anhydrous pure water. Not anhydrous, that's not right at all. Don't listen to what I said. Deionized is the word I'm looking for. To have just pure water like that. So some impurities, well, for one, are even good for you, but other impurities that may even be harmful are okay if they're in extremely small doses. But if you go to Flint, Michigan, no, that water is not okay at all. And if you can analyze it, you might determine that some samples are extremely bad, but you might find that other samples are fine. So you might be able to kind of determine where exactly the problem is coming from. Like maybe it's coming from only one source, certain pipes have a problem, maybe in other parts of the town it's fine. Next, I'd like to talk about inorganic chemistry. Inorganic chemistry is, well, it's the study of not organic chemistry. It's kind of this. So we're usually kind of studying metals. Metals are very, very different than organic compounds, and they're, in some respects, they're just a little more complicated. At least in my opinion, you really have to have a more fundamental understanding of how atoms and how elements are built from the ground up to kind of understand inorganic as compared to organic, at least. And this field is very applicable to, say, materials. Like a civil engineer, you're working with a civil engineer, an engineer who works on construction of, say, a bridge, and they need a new steel alloy for their bridge. Well, you might be able to point out a certain type of alloy that has a certain amount of iron and carbon, so that they can get the properties that the civil engineer wants and needs for their structure. And lastly, I'd like to talk about physical chemistry. Now, physical chemistry is, from more or less, it's physics. You at least for chemists, you really talk about some well, difficult but important concepts. One big one is quantum mechanics. For a long time, scientists kind of had ideas about how the world worked. In the late 1800s, a lot of scientists and physicists kind of thought, like, this field of physics, it's done. It's complete. We figured out everything. Other than a couple minor things, we figured out everything. We've got it. But they started to notice more and more kinks in their theories, more and more little things that just didn't add up. And in science, when your theory starts to have a lot of exceptions, and something's wrong. And it turns out they were wrong. There is much, much, much more to this world than we initially thought. And quantum mechanics is this difficult, non-intuitive topic that explains the small world. It's things like the Schrödinger wave equation that you probably heard of, or Schrödinger's cat, the particle in a box, lots of famous experiments, like the double slit experiment, for example. It all comes down to quantum mechanics. And of course, there's so much more than quantum to physical chem. Next, I'd like to talk about some famous chemists. Now, this is absolutely, in no way, shape, or form, an exhaustive list of all the important chemists who have ever lived, but this is just a couple that I think are interesting, that I think are important to chemistry and, well, science in general. First one I'd like to discuss is Alfred Nobel. He is best known for the Nobel Prize. Alfred Nobel invented a compound that we know today as trinitrotoluene, or TNT, and he deeply regretted that his invention was used for warfare and led to the deaths of people. So, upon his death, in his will, he listed out several prizes that would be awarded to people who bettered humanity. And many people on this list, actually, were awarded Nobel's awards. If you've ever heard of the Nobel Peace Prize, that was among them. Next, we have Marie Curie, who you're probably familiar with. Her most chief kind of discovery was the discovery of radiation, how these molecules decay, and she even discovered an element, radon or radium, I'm blanking on that right now. And of course, that topic was immensely important because it was foundational to future research in things like nuclear fission, nuclear fusion, which are responsible for nuclear power plants, and of course the atomic bomb. Next, I'd like to discuss Rosalind Franklin, who, by the way, just real quick, right here we have our man Alfred Nobel, here's Marie Curie, and here's our next person, Rosalind Franklin. The discovery of DNA, the genetic material that codes life, was largely attributed to Jim Watson and Francis Crick. Now, of course, these two people certainly played a large role in it, but much of their experimental evidence was retrieved from Rosalind Franklin. She most notably used a technique called X-ray crystallography to sort of map out the structure of DNA, and it really, really led to Jim Watson and Francis Crick putting the ideas together. And largely because of her, we now know the structure of DNA, one of the most important molecules that we've ever discovered. Next is Linus Pauling, kind of a physical chemist. Now, Pauling did a lot of work in his time, and he actually, in some ways, contributed also to the discovery of DNA. Linus Pauling is also responsible for the idea of electronegativity. This idea that some elements attract charge more readily than others do, and there's a lot that goes into this, but in general, it kind of correlates with size. Something smaller where the charge is more packed together can kind of more readily attract charge than something larger, at least. Next is Dmitry Mendeleev, the person who discovered. It's hard to say discovered or invented, but he's responsible for the periodic table as we know it today. Periodic table has a lot of really interesting properties. It has a lot of predictive power, so much so that when another scientist discovered an element on the periodic table, they said it had these various properties, but Mendeleev, without testing anything at all, said, no, you must be wrong, because the periodic table predicts the element you discovered to have these properties and to be like this. And Mendeleev was right. His table was so powerful in predicting things that he didn't even have to see something before he knew what it would be, because he knew where it would fit in on the table. It's a very, very powerful tool. Last scientist I'd like to discuss is Fritz Haber. He invented the Haber process. Essentially, this process that, well, it synthesizes ammonia, which is just so incredibly important. Much of all of our agriculture comes down to synthesis of of ammonia as it goes into these various different products to help with agriculture and farming. And this is just one example of how scientists have discovered compounds that have changed the world. All right. So some of you might be wondering, well, why does this all matter? What does it have to do with me? Here, and real quick, I'm also going to move myself out of the way. Oh no, I can't do that. There we go. So I'm not covering up the text. So what does this all have to do with me? Why does it all matter? Well, especially nowadays, in recent years, I think there's been, especially with social media and a lot of people in power, a lot of politicians. There's been so much misinformation, so many misguided ideas that it's sometimes hard to tell what's true and what's not true. But the thing about science is, even understanding some just fundamental ideas from each of the fields, you can kind of understand that some ideas are just ludicrous. For someone to reject some of these scientific ideas, it's just ludicrous. So I have many examples listed on the side. For example, climate change. There are many, well, typically it's Republicans who will deny that climate change. Some will say it's not happening at all. Other people will say humans aren't the cause, or that it's not as drastic as we think. But understand that so many scientists have studied this topic and they've come to the same conclusion. Many independent researchers have realized that carbon emissions, carbon dioxide being released into the atmosphere, contributes to the warming of the planet as it traps heat within our planet. And denial of that is it's completely unreasonable, I think. Other topics like evolution and vaccines, those are also things that people deny. One misconception about evolution is people will say that we evolved from monkeys. Now this just comes down to a misunderstanding of what evolution even is. Us and monkeys shared a common ancestor. Us and anything technically, any living thing technically, shared a common ancestor. And what that means is that there's something that wasn't a monkey, it wasn't a person, it was something probably pretty in between, that existed some years ago, probably millions, even tens of millions maybe, years ago. And then slight differences happen over time, so that that ancestor evolved into pre-monkeys. There's a slight change into those pre-monkeys. Another went down a path of pre-humans. And of course, humans, we have various different species, Australopithecus, Australoneanderthalis, and then monkeys had all their species that came before them. After millions and millions of years, we developed into kind of our own things. Some people claim that vaccines cause autism. There's just no real evidence for that. It's just pretty crazy with a fundamental understanding of them. That some people will claim that. I also notice, especially nowadays, I think this is a really important topic, and that's the many misconceptions about diet and nutrition, which is certainly a science. I have a couple listed, but nutrition's a complicated topic. There's a lot more that goes into it, and you shouldn't just rely on what you see on TikTok or the internet. Heck, you shouldn't rely on purely what I say. really try to look for studies. Sometimes things can be inconclusive, but usually there's at least some semblance of an answer for what you're looking for. Um, for a long time, people thought things like fats are unhealthy. We now know fats are not unhealthy, they're extremely essential, extremely important, especially unsaturated fats, the fats that you might find in things like avocado, olive oil, fish like salmon. Very, very important. Some people will say maybe like natural sugar you get from honey is healthier than table sugar. But if you know a little bit about metabolism, that's not entirely true. At the end of the day, they're both chemically not really any different. And it's kind of just a lie that some people try to sell us. Vegans and vegetarians can't get enough nutrients. Vegetarians absolutely just can. Like they have no issues getting all their macro and micronutrients from all their food. Vegans have a little more difficulty and sometimes do have to take supplements in addition to what they eat, but neither of these types of people are deficient. And this goes for most of the popular major diets out there, like the keto diet. All these diets certainly can be healthy, but focus on that word can be healthy. They can also be unhealthy, all of these diets. I think sometimes people get too obsessed with the diet and less so with the specific food. And at the end of the day, it comes down to eating specific healthy foods that for example, the FDA has studied and found to be healthy. There's a lot of other topics that people don't. There's a lot of other misconceptions out there. Antibiotics and viruses. You might go to the doctor and you might have a viral infection, a sore throat. And sometimes people will just beg and beg a doctor for antibiotics, and the doctor will just give it to you. But the antibiotic's not going to help you. It's not going to do anything. It's really not. It's not going to do anything against the virus. The only reason they gave it to you is because you begged them, and they don't want to get in trouble. They don't want to get sued for doing nothing. That's not doing anything. If you actually understood what was going on, you would understand. You don't need to. Crystals and astrology, I mean, look, there's nothing wrong with having some like superstitions. That's okay. But understand that crystals, while very cool, and there's certainly a lot of science in them, they're one of the coolest structured things out there. I really like looking at those. They certainly have no like healing powers. They're not really used in medicine as far as I know. And astrology can sometimes be mixed up with astronomy, and I think it's kind of given astronomy slightly a bad rap. And there's nothing wrong with, just looking at astrology for fun, but also understand that in some ways it's a little crazy to think that you could, lump all people into just these several categories that you've come up with that are aligned with the stars. We're all different. We're all different people. And to lump us all into like a dozen or so categories, I think is just crazy and not really helpful anyways. Even that has nothing to do with science. I think it's just we all know each other are so different. Things like another big one is gender and sexuality. People sometimes deny kind of the rights of transgender people, claiming that it's not a necessary thing. But understand that psychologists have found this to be a real thing, that people sometimes truly don't feel home in their own gender. Psychology is a long respected field, and there is even some biology to this, of course. Neuroscience, for example. And to say that the conclusions that these scientists have come to, that some people just want to be a different gender, is wrong, is, I think, very, very crazy.